Hi, hello everyone. So welcome back to the Lokinath Lectures YouTube channel. So in this tutorial, we are going to discuss about time complexity and big O notation. So in this tutorial, we are going to discuss the completely about like how an algorithm efficiency we are measuring and the mathematical representation of T of n and simplify it with big O notation. So before going to the concept, so please do subscribe Loknath Lectures YouTube channel. So first, so what is mean by time complexity? So general గా time complexity అంటే ఏంటి? So if we are saying in a definition format, so time complexity means like an algorithm takes time to execute ద ప్రోగ్రామ్. సో జనరల్‌గా ఏం చెప్తాం? సో అల్గారిథమ్ ఒక ప్రోగ్రామ్‌ని ఎగ్జిక్యూట్ చేయడానికి తీసుకునే టైంని టైమ్ కాంప్లెక్సిటీ అని మన జనరల్ పాయింట్ ఆఫ్ వ్యూలో మీనింగ్. బట్ ఇట్స్ నాట్ కరెక్ట్ మేనర్. సో టైమ్ కాంప్లెక్సిటీ ఈస్ నథింగ్ బట్ like how much the time an algorithm takes for different inputs. So for example, if we are saying in simple words, so for larger inputs, while giving the larger input, how much the time an algorithm takes to perform that specific program, and while giving the like a smaller input, how much the time taking for execute the program or perform that program for algorithm. So the both the things we need to identify. So while giving input in a larger manner, in a smaller manner. So while giving smaller, so smaller input ఇచ్చినప్పుడు and లార్జర్ ఇన్పుట్ ఇచ్చినప్పుడు అల్గారిథం పర్ఫార్మెన్స్ అనేది ఏంటి డిఫరెన్స్? సో వీఆర్ క్యాలిక్యులేటింగ్ ఆర్ వీఆర్ కౌంటింగ్ ది ఆపరేషన్. సో వీఆర్ మెజరింగ్ ది టైమ్ కాంప్లెక్సిటీ. సో వైల్ గివింగ్ లార్జర్ అండ్ స్మాలర్ inputs on the performance of an algorithm. So it's not measuring in a execution time in a seconds or actual execution time on hardware on operating system. So not other any factors we are not considering here. We only focus on the count of basic operations. The count of basic operations. So I hope you guys are understand what is meant by time complexity. So while giving larger or smaller inputs, how an algorithm perform while giving different input sizes. So the time we are considering, it's called time complexity. So why it is important? So it helps to compare the two different algorithms, and it helps us choose the best algorithm from two algorithms as well for larger input sizes, and predict the performance of an algorithm without any actually running the code. So before going to run the code, we need to predict the actual performance of an algorithm or execution of a code. So what it counts? So what it counts means like in a time complexity, we count the arithmetic operations and assignments and comparisons and array access and function calls. So the things were count in a program in an algorithm. So here we are representing T of n. So T of n means it's a big O notation. So T of n is called like T equal to time taken by an algorithm and n is size of the input. So T represents the time complexity of an algorithm as a function of input size of n. So how it would be obtained? T of n means like look at the algorithm code first and identify the basic operations and count the how many times each operation runs and express the total count as the function of n. So for the example one, if you guys are observing, if an algorithm performs 3n plus 4 basic operations for input size of n. So we are writing in a example or in a formula format, in a mathematical representation format, T of n equal to 3n plus 4. So this is the just a example one. So we'll explain to you by the taking of an example problem or example things. So why use T of n notations means like we are checking the independent of mission speed and long ways or hardware. So it's clearly shows how much the time taking for growth of growth the growth of the time. So while giving the input size increases, and it helps us like analyze and compare different algorithms and its efficiency. So this is the example program. So if you guys are observing this program, example program, it's just a simple example program. So in this program, if you guys are observing how many operations we have performed in this example program, and how many operations are performed and executed. So the counts we need to find. So here, if you guys are observing, int I comma int n equal to 5. So this int I comma n initializing only one time. So initialize n and I equal to one time. So here I equal to 1. So here we are initializing the I value in a for loop, right? And it is a condition I equal to, sorry, I less than or equal to n. It is a condition. It is an increment I plus plus. So here if you guys are observing I equal to 1, initializing I loop one time. So I less than or equal to n. So here we are checking the condition. We are check the condition and run n plus 1 times. So that's why we are mentioning here n plus 1. So next, print hello. So this is a print statement. We are runs it n times. Why? Because so here we need to check the n number of times. N number of times. How many number of times we are giving? We are running the loop, so that many number of times the print statement will execute that print statement. So n times and I plus plus. So the increment will be depends on the n value, and the return type is 0. So here the return type statement will be executed only one time, or executed or performed only one time. So like this, we need to count the operations in a program and calculate the T of n. So here if you guys are observing, here we are calculating the T of n value. So these things, so here we are having the values. So by the using of this all the values, we are calculating T of n value. So here 1 plus 1 plus n plus 1 plus n plus n plus 1. So here if we simplifying this these values, so T of n values, so expand n plus 1, n plus n plus n plus 1. So here if you guys are observing clearly, so after simplifying we are getting the, so 4 plus 3n. It means like 3n plus 4. So t of n equal to 3n plus 4. So exact count. So for this given or for this discussion example program, so the exact time complexity equal to t of n equal to, so 3n plus 4. So here if we are observing, so here we are applying the big O rule. So the first we are discuss about what is time complexity and why it is important, and the next we are going to discuss, and the next we are discussed about related to mathematical representation of T of n, and the next we are going to discuss about applying big O rule on time complexity. So after we simplifying T of n equal to 3n plus 4. So this is the time complexity we are getting, right? So for this one we are applying the T of, sorry, big O of rule. సో ఈ టైం కాంప్లెక్సిటీ వాల్యూని టీ ఆఫ్ ఎన్ ఈక్వల్ టు 3n+4 వాల్యూని, సో మనం బిగ్ ఓ రూల్ అనేది అప్లై చేస్తున్నాం. సో బిగ్ ఓ రూల్ అప్లై చేసినప్పుడు ఏంటి, సో బిగ్ ఓ రూల్ ఈజ్ వన్ ఆఫ్ ద notation from the asymptotic notation. So here we are ignoring the constant values, here we are ignoring the coefficient values, and here we are ignoring the low order terms. So if you guys are observing T of n equal to 3n plus 4. So this is the original function, right? So here we are ignoring the constants. So constant means, so here we are ignoring the 4 value. And here we are ignoring ignore the coefficient. So coefficient means 3. So the last thing is T of n equal to n. So the final big O notation means like big O of n. T of n equal to big O of n. So big O focuses only on the dominant term since it determines the growth as n becomes very large. So the big O rule only, the big O notation only focuses on growth rate of n value. So ignoring the constant and ignoring the coefficient and low order terms. So this is the conclusion one. So if you guys are observing the conclusion, so count the number of basic operations we have performed in a algorithm and write the exact time function. So T of n equal to, and remove the constant values and coefficient values while applying the big O notation, and keep only the dominant term, which is the growing value, and write the final answer using big O notation. So for example, if we are observing, so this is the one we are done by the taking of example. So the final big O notation value we are mentioning here, like T of n equal to 3n plus O. So the big O value is big O of n. So big O notation tell us how the running time of an algorithm grows with the input size, not exact the number of operations. So here if you guys are observing, so the big O notation tell us how the running time of an algorithm grows. Grows means like while giving the input size larger and while giving the input size smaller. So the growth rating of an algorithm will explain the big O of n value. So not the exact count of operations. Okay. So please do subscribe Loknath Lectures, and thanks for watching our videos, guys. Please do subscribe. And one more thing, so the notes is available on Instagram page. So please follow the Insta page also, Loknath Lectures, with the same name of YouTube channel. And one more time, please do subscribe Loknath Lectures. So happy learning. Thank you. Thank you so much.